minutes to take a look at these questions. Let's answer them and see if you got them right. So we're changing the bases to match. On the left-hand side, we have a base 2, so on the right-hand side, we want to change 1/4 to base 2. So I'm going to have 2x minus 2 on the left, equaling 1 over 2 squared, all to the 2x plus 1. Now I need to change that 2 squared into a base 2, because right now it's 1 over base 2 squared. So I'm just going to flip it back up top and make the exponent become a negative. So I've got 2 to the x minus 2 equaling 2 to the negative 2. Now all multiplying by the exponent, it's going to come down in brackets, 2x plus 1. Now we have to multiply the exponent with the negative 2 into the brackets. And I can drop my bases and solve for x. So I end up with x minus 2 equaling a negative 4x minus 2. Now I need to take my negative 4x to the right, so I'm going to add 4x, there's a hidden 1 in front of this x, and I also remove my negative 2 and take it to the right, and I'm going to take it to the right by adding 2 to both sides. So now I'm going to get 5x equaling 0. I divide by what's in front of x to get rid of it, and I find out that x equals 0. Okay, take a few moments and write that down and check your work. Okay, let's take a look at letter E now. You're going to notice that there's a coefficient in front of the 4, and there's no exponent on the right-hand side. Because there's no exponent on the right-hand side, I'm able to divide the 2 out from the left and do the same thing on the right. Now I'm going to change both my left and right side to base 2. So the 4 becomes 2 exponent 2, all to the 2x plus 3, equaling 2 to the negative 1. Now I'm going to multiply my 2 into my other bracket, and I'm going to get 2 to the 4x plus 6 equaling 2 to the negative 1. My bases are now the same, so I can drop them. So I get 4x plus 6 equaling negative 1. Now I just solve for x normally. So what I'm going to do is I'm going to take my 6 to the right-hand side by subtracting 6 to both sides. I'm going to get 4x equals a negative 7. And again, your last step, dividing by what's in front of x. So we get x is equal to negative 7 over 4. Check your work, and we'll move on to letter F. Okay, letter F, we have all different bases. So we need to convert to base 3. 9 will convert to base 3, and so will 81. So that's exactly what we do. So on our top, we've still got 3 to the exponent m minus 6. On the bottom now, the 9 is going to become 3 squared. So I'm going to have 3 squared multiplying by the exponent that's in brackets, 5m minus 1. On the right-hand side, I'm going to have 81, which is a base 3. It's 3 exponent 4 timesing by the m. Now on the left-hand side, I need to multiply on the bottom the 2 into the brackets. So I end up with 10m minus 2 as my exponent. Since my bases are the same on the left-hand side, I'm going to use my subtracting exponents law for division. So if I look at a normal example, a basic example I have, for example, if I have 5 to the 14 dividing by 5 to the 3, I'm going to take those and subtract my exponents because my bases are the same. I will get 5 to the 11, which simplifies. So now I'm going to do the exact same thing. On the right-hand side here, or on the left-hand side of my equation, I'm going to take my m's and subtract them. So I've actually got this. I've got 3m minus 6 subtracting what I have on the bottom, which became my 10m minus 2. And this is all equal to 3 to the 4m. Now I need to multiply the negative sign into the bracket on the exponent. So that's actually a hiding negative 1. All it really does is it changes the signs on the inside to the opposite. So this becomes 3m minus 6 minus 10m plus 2 equals 3 to my 4m. Now I combine my terms in my exponent as my last step. I get 3, I add my m's together, so I'm going to get negative 10m and a 1m to give me a negative 9m, and then I'm going to add my constants, which is negative 6 plus 2 to give me a minus 4. And that is all equal to, on the right-hand side, I still have 3 exponent 4m. Now that I do have my bases the same and I've simplified my exponents, I can drop my base and solve for m. My base drops, and I get negative 9m minus 4 equaling 4m. And now I solve for m using opposite operations. I'm going to bring my 9m to the right-hand side to visit the 4. To move it over, he's a negative, I must add 9m to both sides. This gives me negative 4 equaling 13m. My final step is always dividing out the coefficient of the variable. I'm going to divide both sides by 13 so that I have m by itself. Now I've got m equaling negative 4 over 13. And now I'm finished. The next section is for you to practice. Have a practice and we'll take a look next time. Okay, now that you've had a few minutes to practice, we're going to look at our last slide here talking about base E. Base E is talking about a ruler's number. Now a ruler is another mathematician just like Pythagoras, and he came up with an example of another irrational number like pi, and base E is another irrational number. If you type in e exponent 1, you're going to get 2.718 repeated. So that is exactly what E gives us as an irrational number. It is run on just like pi is. Now, when we solve equations, we do the same thing with base E. As long as our base is the same, we can drop our base, and we solve for our exponents, our letter x. So we're going to get 3x plus 4 equaling 5x minus 12. We solve for x. So now I'm going to take my 5x to the left by subtracting 5x to both sides, and I'm going to take my 4 to the right-hand side by subtracting 4 to both sides. 4 disappears on the left, and the 5x disappears on the right. I now add like terms on both sides. I'm going to get a negative 2x equaling a negative 16. Last step, as usual, I divide by the coefficient in front of x. I divide by negative 2 to both sides. I will find that x now equals 8. So there's no difference solving for base E equations. We still drop the base if they have the same base. The next section is the practice questions for you to do. We will take them up tomorrow.